d square equal to, and sorry, 2a have cancelled, so d square and a plus sine 2la by 4l and sine 2la by 4l. So 4 has already been simplified with 2, so 2l, and plus we are having for this, when I put here g square, so g square from here is d square e 2ka cos square la and e minus 2ka. So here 2ka and here 2ka will cancel with each other and we will have only cos square la and this divided by k. So this whole is equal to 1. Now I know that what is the value of k here. So the value of k, I can write that k from this equation, I can write that this is L tangent LA. So I can write here L tangent LA. Now tangent is sine by cos, so I can simplify with this cos square LA, and so putting this value in simplifying, similarly writing this one is sine 2LA, I can write now is we considered the potential or the geometry of our potential like this, that the width of our potential well is 2a and the potential applied is finite and minus v naught. We found the solution in terms of the transcendental equation tangent z equals z naught square by z square minus 1. We have k equals minus 2me over h bar and the numerator is in the square root, while L we supposed is 2m e plus v naught square root divided by h bar. We suppose that z is equal to LA and z naught we supposed is 2m v naught over h bar. So this was our supposition that we did. Here we are having a as well. So based on our this, we found the solution. We plotted tangent z, and these are only the even solution. The odd solutions are here, and it will come like this. The z naught square by z square we have plotted, and the cross sections or the touching points are actually the solution of our finite square well. Now we are discussing two limiting cases, and the very first case that we discussed, when we are having a very wide and deep well. Now when this well will become very wide and it will become very deep. So in this situation, if I look at this one, then z naught is equal to this. When it will become very deep, then v naught will have very high value. Then it means that this situation can be achieved when z naught will be very, very greater. So when z naught is very greater, then what will happen to our solution? So think, when z naught is very greater, this line, the pink line, is actually z naught by z square minus 1. When z naught will be very greater, then this line will move up and we will have our intersection point somewhere very close to this pi by 2. Similarly, we will have it very close to 3 pi by 2 and so on. So I can write that in this situation, when z naught will be very greater, our solution will come very close to the pi by 2 multiple here. And this multiple will be the odd multiple. The pink line will rise up. So we will have, as z naught is any point on the z axis. So the pink line is going on, and when z is equal to z naught, then we will have 1 minus 1 and we will touch the 0 point here on this axis. So when z naught is very greater, so let me consider all zn values. So it will be equal to n times pi by 2, because our solution will come very close to this one, n odd pi by 2 or 3 pi by 2 or pi by 2, because the pink line will rise up. So squaring this one means zn square will be n square pi square over 4. So we will have this equal to this. Now what about z naught? Z naught square from here is a square over h bar square 2m v naught. Z naught square is equal to this. So we are having our L equal to this as well. So let's see from here that when z naught square is very greater, then we will have this as a dominant term. The minus 1 will not affect it much. So I can write the tangent z is equal to z naught, approximately equal to z naught over z, and I can write that z tangent z is equal to c naught approximately. And this will make our calculation easier. Is I know the tangent z and z is equal to LA. Whatever means z is an infinite variable, it will change. So whatever the value, how much the z naught be greater, this value it will be less than z. So I can say that the z for tangent z goes to approximately z for z very less. We know sine of theta goes to sine of theta, because tangent x is equal to sine x by cos x. If x is very small, then sine x goes to approximately x and cos x goes to 1. So tangent x goes to x for z very less, and I can approximate this one, that z into z square is approximately z naught squared, and z square then I can write is L square a square is approximately z naught square, and this I can then write that for L square I can put the value, and it is equal to, it is a square, and then L square I can write 2m and E plus V naught. But here this 2m V naught, it will be squared, so we will have to write like this, h bar square 2m E plus V naught, and this is the value of L square and this is a square, is equal to Z naught, and Z naught value from here is n square pi square over 4. Now as I am writing not only one solution but n, while n being odd, so I can write here the index n as well. So this is equal, now I can further write this one, that I can move it here and then a square down. So this will be that En plus V naught is approximately n square pi square, and then h bar square will come in here, and a square will come down, 2m will come down, so 2m and then 4a squared, so 4a squared, this I can write equal to n square pi square h bar square divide by 2m, and this I can write is 2a square. Now if I consider the infinite square well, then in the infinite square well we were having the energy En is n square pi square h bar square over 2m a square. Over there the width of the well was a. With us the width of the well is 2a. So this somehow seems to be the finite square well energy, but with finite V naught. And if I consider that V naught is infinite, then we will have the infinite potential will cause this energy to be the energy of the infinite square well. So we will reduce the finite square well goes to infinite square well by considering its potential too deep, means too deep and too wide. So when this potential will go deep, it means the potential becoming on the walls, it will become infinite, and we will reduce the energies to the infinite square well energies. So this is one of the limitation of this finite square well. Another limitation, we can take just the opposite of it. When it will not be wide, it will be narrow, and not deep, so it will be shallow. So let's consider another limitations in this, and the next limitation is that when we consider a narrow and shallow, means not much deep, shallow well. So in this situation we will have to consider the Z naught to be very, very small. So this can be achieved by when we consider Z naught very, very small. Now Z naught up to here we consider, and we got 3 solutions. If it will be less, then we will be left only with one solution here. And when this Z naught square is very, very less, so it will be touching it down, it will come down, the pink color will come down here. But how less it will be the Z naught square, it will go down, 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 is in this one is touching it 0. So for even the weakest value of Z naught or the weakest value of this shallow well means the V naught, we will have only one solution possible always. Now there will be, for the lowest value of Z naught, the odd solution will not be possible. Only one solution or only one bound state will be possible. Only one solution means there will be always one bound state possible. So we will have always the possibility to have one bound state, and Z naught will be very less. So when Z naught will be very less, this line will come down, and here on this axis we will come closer to the origin, and we will have a shallow and narrow well, and only one bound state will be possible always. So only when Z naught will be approximately pi by 2, or we will say that it is less than or equal to pi by 2, so only one solution will be possible, and this pink line will actually go much closer to this one, and we will have one solution possible always, because this line will have to start above the zero value, and the tangent is touching 0 here. So always we will have one solution possible. How much the well to be shallow and narrow, one solution will be possible always. We can make this one much closer than this one, and even then one touching will occur here, one cross section will occur here, and we will have the intersection is the solution. So one solution is always possible. How much the level or the where the well to be shallow and narrow.